Engineering simulation is a powerful tool for designers, but the reality is that many don't understand how it works. In this brief example, I'll show you how this technology aims to teach you about the underlying physics of your design. To get started, I'll import a small assembly on which I want to perform a structural simulation. Some basic assumptions I'll establish is that a bearing in the center will produce a downward force on the pillow block, and I know the assembly should be secured at the outer mounting holes. With that in mind, I'll initiate a structural simulation, choose a material type, and select the body on which to perform the simulation. The only other aspects to cover are defining the load and supports. As I go through this setup and view some results, I'll be able to discover what's going on in the model. That is, knowing how an applied force affects the design, or knowing where stress concentrations will occur. And as a novice simulation user, ultimately interested in the physics, this will tell me a lot. First off, I can see a high stress concentration located at the fixed support cylinders. That strikes me as odd, as it's probably not where the highest stress should be on this model. What might make more sense is to also apply a fixed support to the bottom faces. Instantly I see the unneeded stress concentration goes away as I've more accurately applied fixed supports. As I look elsewhere, I see the highest stress occurs towards the top of the bearing face, but that too doesn't make the most sense. What's happening is the entire face is being pulled down at every single location, which in reality doesn't happen. I just need to adjust my loads. Discovery Live has geometry editing tools that are just as easy to navigate as the simulation tools themselves. It's simple to do an approximate partition of this face into two regions, then make sure the load is applied to the lower face since I'm testing a downward force. Now that my setup more closely resembles real-world conditions, you can see the high stress concentrations towards the bottom of the pillow block. As I'm better understanding the physics behind the model, it's easy to start experimenting with different techniques to alleviate stress concentrations. In this case, I might put a rib in the center of the block, and I see that it lowers the stress by almost an order of magnitude. Of course, I could further modify my design and see how that affects the performance. But at the end of the day, I'm learning about physics in general just by having access to a tool like Discovery Live. To better understand the physics behind your designs, start with a free trial of Discovery Live by visiting ansys.com/discovery. Thanks for watching.